Hi everyone, we are the Group 5 of Class 40432 Waste Management. So today we are going to record a video, and this video will study one of the important hazardous waste, that is sewage sludge. We will study its related treatment techniques and consequent environmental impact in the urban cities like Hong Kong. By reporting our findings, this video aims to educate the public of the importance of the hazardous waste. So, as you all know, sewage sludge is the semi-solid residue produced during the sewage treatment of the industrial or municipal wastewater, and it is a byproduct of the sewage treatment. So, Ziqiu, could you introduce us to some of the environmental impacts that the sewage sludge treatment would generate? And we'd also like to know if there are any advanced techniques that could be used to handle the treatment of the sludge. Thank you.
Oh, thank you. Hi, dear listeners. My name is Wang Ziqiu. I would like to introduce the environmental impact in an advanced sintering technology. It is centrifugal sintering process. This process uses centrifugal force to throw the water out of the solid. It can be easy to notice that this kind of machine uses a lot of energy. Actually, 100 kilowatt-hour is needed to treat 1 ton dry sludge. If all the waste treatment plants in Hong Kong use this kind of technology, it will equals to 5.4 tons of carbon dioxide and 0.04 tons of sulfur dioxide emission. It is quite a large amount number. The other environmental impact is that the rotating part is always moved at a really high speed. It can generate a high level noise. It can reach about 85 dBs when it is working at a normal power rate. So I think you will not want to live nearby such a kind of machine.
Welcome to anaerobic digestion. AD is a core decomposition process in sewage treatment which converts the biodegradable portion of phytic sludge into biogas and digested. Biogas can be further harnessed to produce energy through combined heat and power generation. AD has been globally acknowledged as a low-emission technology, but it is also a potential pollution source if not designed and handled properly. First, climate change. The major component of biogas, which is methane, is one of the potent greenhouse gases, and only 5% leakage of biogas can cause fugitive emission. Also, during stage P, in which methane is burned to produce electricity, the flue gas after combustion consists of nitrous oxide and sulfur dioxide. These two can cause acidification in soil and surface water, and they are also sources for secondary cultivated matters in the atmosphere. Second, eutrophication. The nitrogen-containing byproducts after flue gas combustion can cause eutrophication if emitted into the environment. Digestate is also a potential inducer of eutrophication. Third, photochemical oxidant pollution. The non-methane VOC has been reported to account for 70% of total photochemical oxidant pollution. However, these three environmental issues are not insurmountable. Actually, they can be effectively controlled by installing flares and flue gas cleaning systems to avoid emission of these pollutants. Thank you.
After anaerobic digestion, the sludge still contains large amounts of water, which is unfavorable for the subsequent landfill, composting, or incineration of the sludge. Therefore, dewatering processes are applied to remove the water content of the sludge. And besides dewatering itself, conditioning is usually used to pre-treat the sludge so that it can have higher dewaterability, so that more desirable sludge can be attained. However, the dewatering processes as well as the pre-treatment have been having these drawbacks. First one is the high energy demand of the dewatering processes, and the second one is the use of chemical conditioners to pre-treat the large amount of sludge produced each day. And these have been found to be contributing to the climate change, eutrophication, human toxicity, and ionizing radiation. To improve the environmental performance of the dewatering processes, two of the most popular
methods are firstly to improve the energy efficiency of the dewatering processes, and the second is to reduce the use of chemical conditioners and replacing them with more environmental friendly alternatives such as the physical and biological conditioning. Thank you.
Sewage, as you can see every day in your life, is quite easy to be disposed of, right? Flush it into the toilet and off you go, nowhere to be seen. But what happens afterwards? What happened to the solid residing in sewage? One of the ways to dispose sewage sludge is to use a traditional landfill method. Generally speaking, such strategy may cause certain impacts on the environment, including contamination of groundwater, release of toxic gases. In the following section, the problem of such adverse effects shall be discussed. First, the case of China's sewage sludge treatment shall be mentioned. According to Wang, the percentage of landfill used on sewage sludge disposal scored a significant 65% in 2010 and reduced to 20.1% in 2019 due to the adverse effects, for which the method of landfill as mentioned will cause numerous possible impacts such as groundwater contamination, CO2 emission, high heavy metal composition in soil, etc. To tackle with high proportion of sludge being treated by such disposal method, the two pre-treatment methods where the issue might be settled with, as other group mates would have mentioned.
Hello, I'm Ben. I'm going to introduce the environmental impact on the incineration for the sewage sludge. Incineration and the landfill are the ways to deal with the sewage sludge. According to the article from Leo and his team, they compare the traditional landfill handling and free incineration treatment progress with the dry incineration, which are the dry incineration treatment, co-combustion with coal, and co-incineration with municipal solid waste. The energy consumption of the co-incineration with the municipal waste is significantly lower than the other two incineration methods because of the recovery of the internal chemical energy of the sewage sludge. However, this would provide less energy recovery. According to the Wang's research, carbonization has the best result on the life cycle assessment for the sewage sludge treatment, and this method can convert the sewage sludge to the biocoal, which can partially substitute for the coal during the power generation. Therefore, I believe the carbonization of the sewage sludge is a highly sustainable option. Okay, students.
So this is the end of presentation, and thank you for watching. Bye.